Has anyone seen Black Mirror, where you walk around and you've got that little social score going on about you? Well, that's all controlled by algorithms. Well, what happens when decisions are made about us in this way? Well, here to discuss this really crucial issue, especially for the next few years, will be Patrick Bull with HRDAG, and Brian Brackeen from Kairos, and Christian Lum from HRDAG, to discuss this. These people are human rights data scientists. Yes, I knew. I didn't realize that was a job myself until recently. Megan Rose Dickey from Techcrunch will be leading the discussion. Please join us. Big round of applause.
Thanks for joining me up here. I am excited to delve into what is a very important topic, algorithmic bias, algorithmic accountability. Brian, I wanted to just kick things off with you. You're the founder of Kairos, a facial recognition software company, and you're actually doing a demo a little bit later today on the main stage, so quick plug. But so it was a few months ago you published this post on Techcrunch.com about how your company will never provide its facial recognition tools to law enforcement. Why is that?
Yeah, we get concerned about algorithmic bias, actually, is like the core reason why. So, and for our regular use cases, we do facial recognition for like the Fortune 100, Fortune 500. These are people like banks, retailers. So if we're wrong, at worst case, maybe you have to do a transfer again on your bank account. If we're wrong, maybe you don't see a picture where you're during a cruise line or something like that. But when the government is wrong about facial recognition, it's someone's life or liberty at stake, right? They could be putting you in a lineup you shouldn't be in, right? They could be saying that this person is a criminal when they're not. Then with all the issues around just law enforcement in general, it then just kind of spirals out of control.
And I want to talk a little bit about the different types of biases, because what's the specific type of bias that leads to some of the misclassification?
So there's all kinds of different kinds of bias, and we'll probably go through the different types. But in our world, facial recognition is all about human biases, right? And so if you think about AI and it's learning, it's like a child, and you teach it things, and then it learns more and more. What we call like right down the middle, right down the fairway, is pale males. It's very, very good, very, very good identifying somebody who meets that classification.
Pale male.
Pale male. That's right down the fairway. That's
I know some of them.
Okay, yeah. I've never actually heard it called that. I like that. Pale male.
Those walking around, yeah.
Yeah.
And then as you get further the fringes, right, you get, women, folks of different ethnicities, darker skinned folks, even within, let's say, African Americans, you have different shades, right? The further you get from pale male, the harder it is for AI systems to get it right, or at least the confidence to get it right.
And Christian, maybe you can speak to this, but why is that?
Sorry, why is
it that it gets harder the further away you get from pale males?
So, I think there are a couple different varieties of bias that we're talking about, and I think the one you're really getting at is sampling bias, right? So you have a lot of examples of, and it's funny because I hadn't heard that term before, so I'm probably going to laugh now, but, pale males, and so your training algorithm can learn a lot about those types of faces, right? But when you have other categories, or maybe you have fewer examples, there's less data from which to learn, and so it's harder to make those classifications, or harder to correctly identify people, or whatever your application area is. Yeah.
Mm-hmm. And Patrick, there's another type of bias. There's selection bias. Mm-hmm. What is that, and how does it differ from the other types of biases?
In a lot of contexts in which we want to use machine learning, we go out to find data that we can use to train whatever model it is we're going to apply to make predictions. Well, where do we get the training data? Training data in a private sector context probably comes from business process. And if it comes from business process, you can be reasonably confident that the data you've captured is representative of your business process. So the only assumption you have to make is that the business process in the future will be similar to business process in the past, and you're good to go. Social data, particularly in the public sector, isn't like that at all. The way we get data from public sector processes is through administrative interaction with people. So think about policing data. How do the police get data on people? Well, police get a lot of data about people that they police intensely. Whether or not those people are criminal, they have frequent interactions with the police, and every one of those interactions becomes a data point in a database. People who rarely interact with the police have much less data about them in those databases. If you use those databases to train models about who is a criminal or who should be released on pretrial release after they've been accused of a crime, the model will tend to think that people who have frequent interactions with the police are more criminal. Okay, so the consequence of more frequent interactions with the police is that you're more likely to have a more dangerous prediction from a model making a prediction about criminality. This can be catastrophic. What we're doing essentially in a model like this is reproducing the bias on the input into the predictions. And this is a very common problem in public data. It affects credit scoring. It affects all these criminal justice applications that I mentioned. And it affects national security applications of risk classification. It's a giant, giant problem, and it's getting much, much worse. It's not getting better.
That this person is a criminal when they're not.
Focusing on the first neighborhood. Criminal justice, in my opinion, is probably the sharpest example of application of these tools in criminal justice applications.
Number one.
Yeah.
Yeah.
For fair predictions, you first need a fair criminal justice system.
Right,
and
which we don't.
It's easier to get access to something like an API, or something like a model